My name is Marco Baringer. This movie is an introduction to the common Lisp development environment, Slime. The first thing we're going to do is we're going to download, install, and set up Slime. For the purpose of this demo, we're going to be running Slime on a remote machine, and we're going to connect to it from our local Emacs. So let's get Slime. Anonymous. The best way, in fact, really the only way, to use Slime is to always work with the latest CVS version. If you happen to use a released version and you run into a bug or there's something that doesn't work, the first thing everyone's going to tell you is to grab the CVS version and try with that. So you might as well start directly with the real thing. So now we've downloaded Slime. We're going to be using SBCL. This is an x86 machine. The first thing we need to do is we need to tell SBCL how to load up Swank. Swank is the Lisp side of Slime. Slime has two parts, Emacs and Lisp. Within the Lisp implementation, Slime actually runs a network server that reads and handles requests coming from Emacs. This characteristic is what allows us to run Slime on one machine and run Emacs on the other. So let's go to Emacs. Let's go set up the file .sbclrc. This is Slime's initialization file. This is run whenever this is SBCL's initialization file. This is run whenever SBCL starts up. And what we're going to do here is we're going to tell SBCL that it needs to use ASDF. ASDF is a make type program, and loading Swank is done through ASDF. And we need to tell ASDF that it should look for system definition files in a directory called home segv systems. ASDF central registry. Save the file. Now let's go back to our terminal on the remote machine, start up SBCL. What we're going to do is we're going to load Swank. Of course, we told ASDF to look for system definition files in a directory called systems, but we didn't make the directory, and we certainly didn't populate it with Swank's .asd file. Let's try again. Operate on system, ASDF load op, load Swank. Okay, so now Swank's compiling. Let's go here. We have Swank running on a remote machine, so we need to somehow connect and send our requests back and forth. We don't want to, and actually I can't at the moment on that machine, open up Swank's port to the entire world. So what we're going to do is we're going to set up an SSH tunnel between the local port 4001 and the remote port 4005. There we go. Now let's go back to our SBCL buffer. The other thing we're going to need to do, when Slime communicates with Swank, and when Swank communicates with Slime, it will attempt to use a second port, a second stream, just for the output. This tends to make things significantly faster, and it also helps avoid, if I remember correctly, certain odd hangups. Use dedicated output stream. We're going to turn that off since we're only allowing one stream between our local computer and this remote development machine. So we're now ready to create the Swank server. So now Swank is up on the remote machine, and we can go back to our local Emacs, and we can configure Emacs .emacs.d Now, I've already got my own slime configuration file. I'm not going to go into all the stuff I have in here. I'm just going to concentrate on these first few lines, which is what you really need. You have to tell Emacs where it finds the slime.l file. Notice this is a local directory. You need to make sure when you're doing this that you're running the same version of slime on both machines. We then require slime. We tell Emacs that when it loads up a list file, it should jump to slime mode. That's what this call does. If you run slime locally, if the Lisp is on the same machine as Emacs, then Emacs will start up the Lisp by calling the inferior Lisp program. This executable should start up your Lisp. The indent function, we want to use common Lisp indentation and not eLisp indentation. Complete symbol function, I really like fuzzy completion. Slime offers a couple different kinds of completions. This is the one I'm going to use. If you want to look in the documentation, there are other completions available. The common Lisp hyperspec root, well, I have a local copy of the hyperspec installed so that I can then go and jump immediately to the documentation for standard common Lisp symbols instead of having to go out to lisp.org or lispworks. And the startup animation, I generally turn this off. I don't really like it. For the purpose of this demo, I think we'll turn it on. Last thing we need, since we're running on a remote machine and we're developing on a local machine, we need to tell Slime and Emacs how to translate the file names. That's what this code down here does. Okay, translate to Lisp file name, takes the name of an Emacs buffer, and converts it into the name of the corresponding file on the remote machine. Translate from Lisp does the opposite. Okay, basically, in this case, since I'm using tramp, you can see the buffer file name here. All this amounts to is adding and removing this SSH username and host prefix, which is exactly what this does. Well, now we're ready. Slime connect. Since our Lisp is already running, we don't want Emacs to start up its own Lisp. So we use slime connect, and it asks us what host and what port it's listening on. Thanks to the SSH tunnel, we're running on the local host, port 4005. And now, here we are, directly in a REPL. We can start typing away. Okay. This is running on the remote machine. If we have a look at what default path name defaults is, home segv, you'll just have to trust me that that directory doesn't exist on the local machine. And now we can do, through this Emacs on this machine, anything we want on the remote machine. First thing we're going to do is we're going to talk a little bit about the REPL. Now, trying to decide what to start with, and I never really know. Let's start with the Slime REPL presentations. These are actually pretty interesting. Now, I'm sure you all know about these variables, star, 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 and star, 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 which allow you to get at the objects returned by previous evaluations. Well, Slime has something called, I believe the technical term is, output presentations, which allow you to get at any value that's ever appeared in this REPL. And I'd just like you to notice that this, even though it looks like a string, is not a string. It is in fact a marker representing the actual object. Okay, as we can see there. There is no string marshalling and unmarshalling going on. Okay, it's just a very convenient way, pardon me, to get at previous values. Next thing we're going to talk about are the REPL shortcuts. If you're at the REPL prompt and you hit comma, it asks you for a command here in the mini buffer. I'm going to type help. Here's a list of all the REPL shortcut commands. These are convenient operations that you do, that you can do from Lisp, or you can do otherwise. They're sort of wrapped up in one simple to use, say, name. let's start with our example. What we're going to do in this example is we're going to create a file which is going to translate from Morse code to Lisp strings and back and forth. So let's open up a new file. On the remote machine. First thing we do is we create our new package. Now, I know how new package works. Okay. Let's pretend though that I'd forgotten. Don't know what the parameters are for new package. We've actually got a couple options. We can use Control D, okay, slime describe symbol. Whenever I use a key sequence, I'm going to open up the key help buffer so that you know what command I'm running. My key bindings are slightly different than what slime ships with. So in case you try something that I'm doing and it doesn't work, make sure that you have key bindings are the same as mine. So let's try running Control C, Control D, D. And here we go, a description of the symbol def package, telling us it's a macro function, and telling us the arguments of the macro. Well, package and rest options. That might be true, but that's pretty useless. However, here we do have the macro documentation. It's this block, okay, which is enough. But if this documentation hadn't been there, we have another option, Control C, Control D, H, hyperspec lookup. I'm going to do that now. Opens up in a browser, in my case I'm using W3M inside Emacs, the corresponding hyperspec page for that symbol, or function, or macro, or whatever. So here we could read all we wanted about description, about def package. Now let's write the in-package form. So now our file's ready. The first thing we're going to want to do, we've written the code, we haven't actually executed it yet. We need to send the code to Emacs. There are a couple ways to send code to Emacs. I'm only going to mention two of them. The first is Control-Alt-X. Okay, slime eval defun. It's a slight misnomer. It should be called slime eval top level. What it does is it looks at the cursor, figures out where the point is, it figures out what is the top level form that contains the point, and it evaluates that. So if I now hit Control-Alt-X, it's evaluated this form, the entire def package form, and it's given us here in the mini buffer the output. Let's drop Emacs down another line. Another option we have is Control-X, Control-E. Okay, slime eval last expression. What this does is this takes the form immediately preceding the cursor, whether it's top level or inside something else or not, and it evaluates that and prints the return value. Let's do that now. And again, we get package Morse. Let's jump to our REPL. And in order to jump to the REPL, I'm going to show off one more feature of Slime, which is the Slime selector. By default, it's not bound to any key. I've globally bound it to the F12 key. So if I hit F12, question mark, it shows me a list of things, places I can go with a short key sequence. In particular, right now I'm interested in this one, read eval print loop. So I hit R, and here I am in the REPL. Now let's check and see if the package Morse does in fact exist, and it does. Beautiful. So let's use one of our REPL shortcuts. I'm going to hit comma here, exclamation point P. Well, we'll use its long name, change package. The mini buffer now asks us for the name of the package we want to move to. We have completion here, so if you don't remember the complete name of the package, or if it has a very long package, in package Morse, and notice that our REPL is now in the Morse package. Let's use the Slime selector again. We'll use L this time to jump back to the Lisp package. We want to convert from Morse code to Lisp strings, and we want to convert from Lisp strings to Morse code. Obviously, what we need here is a table mapping the two. So let's put that in a parameter. And notice that as soon as I typed hit def parameter and hit space, down here at the bottom, I get the lambda list for the parameter. So I know that it takes a variable. Let's call this one Morse mapping. Hit space again. Here it is, reminding me that the next thing is a value. Well, we're just going to use a very simple A list. And it's going to map characters, such as A, to their corresponding string Morse code equivalent. Now, of course, I don't know the entire Morse code alphabet by heart. So what we're going to do is we're going to ask Google to give us the Morse code alphabet. Gotta love that. Morse code alphabet. Let's just copy this whole bit. Let's jump back to Emacs. Paste. Now, I'm going to do a little bit of Emacs macro hackery. Define a keyboard macro. Alright. Redefine the keyboard macro. Open parentheses. Character, one space, end of line. There we go. So full stop, comma, and query are actually period, comma, and question mark. Let's uppercase this just for consistency. Now, I'm going to use Control-Alt-Q, indent sexp, to indent the entire form. Now let's move the cursor inside this form, and I'm going to introduce you to yet another way to send code to Slime, and it's Control-C, Control-C. Slime compile defun. Again, this is something of a misnomer. This should be slime compile top level. We are in fact going to use this to compile a def parameter form. Control-C, Control-C. And here down here we get compilation finished. There are two major differences between this and Control-X, Control-E, and Control-Alt-X. One is that this does not print the return value. It prints this compilation error. And two is that it will generally compile the code with different compiler settings. If your Lisp does support an interpreter, mainly that would be CLisp, you may find code runs slightly differently, or at least with slightly slower or faster, as the case may be. So we've now compiled this form. Just to be clear, what this does is it finds the form, creates a temporary file, puts that form in a file, and then compiles and loads that file. So we've defined our Morse mapping. Just to test, let's define a function which, given a character, returns the Morse string. Okay, this is going to be very simple. We actually want the CDR of this. Now, we've written the file. Tramp is trying to save it. There we go. Let's now compile the whole file. Control-C, Control-K. Okay. Notice that we get, down here in the mini buffer, compilation finished, 0 errors, 0 warnings, 0 notes. So let's go back to our REPL. And let's try calling character to Morse. What I'm going to do here is I'm going to show off Slime's completion. Now, I've typed the initial part of the name of the function, and then I hit tab, Slime complete, and I get here a buffer with the list of all the possible completions. All the functions or macros or variables that contain charac, which is what I had written at the beginning, Here we go, character to Morse. And in this second column, you'll notice I get some brief information about the symbol. For example, I can tell that character is bound to a function, and it also names a class. At the same time, I can tell that all of these name functions. They're not bound to variables, they're not bound to macros, they don't name classes, and so forth. So let's go down to character to Morse, and let's pass it a. Character to Morse, let's pass it m. Okay, this looks like it works. The only difference is that we're getting a string, we're getting a list containing a string. For simplicity's sake, I want just the string itself. Well, we can do that. Now let's redefine the function. I'm going to use Control-Alt-X here, jump back to the REPL, recall it, and there we go. Okay? So that's one function we'll need. Another function we're going to need is Morse to character. Given a Morse character represented as a string, we need to return the corresponding character. We're just going to use find for this, since we don't want to write out another variable mapping back from the Morse string to the character. Find the Morse string. In what sequence? In the Morse mapping. The test should be string equal. The key is the CDR. And of this, we want the second, or the first, sorry. Let's compile the whole file. Let's go back to our REPL. Let's test character to Morse to make sure it still works. Now let's test Morse to character. And let's pass it // The value // is not of type. Well, welcome to the Slime debugger buffer. This is your best friend, your worst enemy, and everything in between. You will be spending a lot of time in here, so get used to it. The value is not of type. What we have up here is a description of the condition, the error that occurred. Then we have a couple lines naming the restarts. And finally we have a backtrace with all the frames. Generally, Slime will show us only the first few frames. If we're interested in more, we just go down until we get to the more tag. And we can get to all the frames we want. When we're on a frame, we can use T, toggle details, to get information about the local variables. For example, Morse to character has a local called arg/arg0. It's bound to the string --. The function find position, I toggled the local variables on that. This tells us how it's being called. Okay, the first parameter passed was this string, and then it was given a list of lists, a list of lists. And we can see here that the other arguments passed were two functions, CDR and string equal. What is the problem? Here, let's toggle this again. We see that we're trying to call string equal, passing it a string and a list containing a string. Well, I think I know what that is. In the meantime, let's show off the V key, show source. This jumps to the source code of the corresponding frame. If I hit V, notice that Emacs opened up a buffer, and here I am on the function. If I go down here, this should not be CDR, it should be second. Let's redefine the function. So we've redefined it. Let's go back to our SLDB buffer. And in this case, we're just going to try the abort restart. The A key, Slime abort, will always run this abort restart. In this case, using A or using 0 would be the same thing. For convenience, I'm just going to hit A. And let's try calling it again, Morse to character. Oh, by the way, Alt-N and Alt-P allow you to move through the history, okay, of your REPL. Morse to character. Here we go. So, let's try something else. Let's try dot slash. Let's try something a bit longer. Dot dot slash slash dot dot question mark. Okay. So it looks like Morse to character works, and it looks like character to Morse works. Let's go. I'm going to use this line selector again. Back to the list file. And let's go and let's write the function that converts an alpha string, in other words, a string of characters, into the corresponding Morse string. The first thing I'm going to do is I'm going to go to the top of my file, and I'm going to add this declaim form. I'm not interested in speed. I'm not interested in safety, actually. I am interested in safety, and I'm very interested in debugging. What this does is this tells SBCL that when it compiles this file, it should keep as much debugging information and write as safe code as possible and not worry about the efficiency of the resulting code. Basically, this assures me that since I'm doing a demo, I'll get at all the debugging information I'd like to show you. Under certain compiler settings, the debugging information is removed, either because the variables are optimized away, or because entire stack frames will disappear if function calls have been inlined, and so forth. So let's recompile the file, just for good measure. We still get no errors, no warnings, and no notes. Now let's start writing the function. Before I start writing this function, I want to talk a bit about some of the tools Emacs offers us for writing Lisp code. You've already probably seen some of it so far in this demo. I'm going to talk about first inserting parentheses together. In other words, when I hit open parentheses, notice that two parentheses were inserted, both the opening and the closing parenthesis, and the cursor was placed between them. So I can type, for example, prink 42. And now when I hit a closing parenthesis, it doesn't actually insert anything. It just moves the cursor past the corresponding parentheses. Had there been any space here, as a convenience, it chews up any horizontal space. Another very useful, so this is inserting parentheses. Now let's talk a bit about navigation. If, for example, I have the cursor here, at the beginning of the defun, I can use the functions, I'll show the keys I have them bound to, forward sexp and backward sexp, to move one form at a time across the code. So the point is going to go after the defun, after the name of the function, after the entire argument list, and now it's going to skip everything in that call to first, all the way to the end of the defun. Another useful tool, transpose sexps. Let's say, for example, I had two forms, and then later on I realized that I'd inverted the order. I can hit transpose sexp, and they're swapped. And they're swapped no matter how deeply, no matter what else is in here. I can put any kind of stuff I want, and they're transposed as complete entities. Okay? Another very useful function is kill sexp. This deletes the form immediately after the point. So for example, if I have point there where it is, we can see that the form immediately after point is this. If I hit kill sexp, the entire form disappears no matter what it contains. If I hit it again, get rid of foo. Now let's undo that, and I can give it a prefix arg, such as alt2, alt2 kill sexp, and both of them disappear. Last thing I'm going to talk about, if we have a form, we write, for example, foo of a, and then we realize that we're missing a. Well, I can give a prefix parameter, such as alt1, to the open parentheses command, and it wraps that many forms in the parentheses. So you can see, for example, this open parenthesis was added, as was this open parenthesis, this last one. Now I use these a lot, so if you see me jumping around and things just appearing or moving, it's due to that. So finally we can start running our function. So let's call it string to Morse. We'll take a string, and we're going to very simply loop for car cross string for Morse, and do character to Morse of car. What are we going to do? We're going to write string Morse. Well, we're missing a place to write it, so let's wrap this with output to string. We'll call that Morse. Indent. Let's go down. It's Morse. This needs to be then Morse car, Morse car. Actually, this turns out to be useless, so let's just do that. There we go. Very simple. Let's compile the file. And let's try calling string to Morse. And let's pass it my name. Well, what we're missing, first thing I notice, is that after every Morse car, we need to write a space. So let's recompile, go back to the REPL, recall it. Because here we're missing the output stream. As opposed to recompiling the whole thing, I'm just going to use Control-Alt-X. Now, the only problem that I can see, it's kind of ugly, is this last space. So, how are we going to fix that? We need to not do that the last time. We'll do it this way. Kill that. And then here, we'll take care of the initial character. Write string character to Morse of car out to Morse, and then nothing, and then here before every character we'll write car space to Morse. Recompile the file. 2 warnings. Well, when we compile a file and there are some warnings or there's some errors, we get a compiler notes buffer like the one you see here telling us what went wrong and where. So let's see, here the warning is the variable car is undefined. Well, that makes sense. So let's kill this. Notice that the form to which the warning was related is underlined in orange. You get warnings in orange, errors in red. Well, hey, let's introduce an error. Let's recompile everything. Let's see what happens. So notice now we have 1 error, 0 warnings, and 0 notes. There aren't any warnings anymore. I actually wanted that warning. I need that to make my point. So let's introduce that again. So now we have 1 error, 2 warnings, and 1 style warning. Notice that when there are more than one, when there's more than one warning or error, we get a tree buffer like this one, where we can go and we can look. So let's first take care of the warnings. This variable is undefined. If we hit, let me move the point away here. If we're at the warning and we hit enter, okay, it jumps us to the point in the file in the buffer where the error occurred. So let's go here. Let's add in that aref string 0. Now, let's look at the style warning. The variable string is defined but never used. Oh, that's not quite correct. It's probably due to this error. Let's have a look at the error. In macro expansion of loop. Well, let's go here. Now, I introduced that error, so obviously I know what's wrong. But let's pretend we didn't realize what was wrong. We've got a couple options. We can go look at the documentation for loop. Open up the hyperspec on loop. Control-C, Control-D-H. We can jump to the source code definition of loop with Alt-dot. Well, we can't because loop was compiled without source code definition. We could, generally speaking. We can try and describe the symbol and see if there's any documentation associated with the macro function. In this case, there isn't. So what we could do now is we could try just macro expanding it and see what happens. Well, Control-C ret, macro expand 1, takes the form currently under the cursor and simply calls macro expand 1 on it. And of course, in this case, we get into an error buffer because it wasn't able to macro expand it. Compound form was expected, but 4 was found, blah, blah, blah. Let's abort. Let's fix that by removing the do. Now let's try macro expanding again. And notice that this time, we get the code. So things are working. Let's quit. Let's try compiling the whole file again. 0 warnings, 0 errors, 0 notes. Good. String to Morse. Beautiful. M, I know this is A, and I'm just going to trust that these are R, C, and O. So now we have string to Morse working. Let's try and write Morse to string. Now we're going to assume that string is a string of dots and dashes separated by spaces. So the first thing we need to do is we need to split string into all the different characters. Well, how are we going to do that? I'm not going to sit down and write the code for splitting string. What I am going to do is I'm going to download it off the internet. We're going to load up something called ASDF install. This is a tool built on ASDF, which allows you to install automatically common Lisp libraries just by running ASDF install split sequence. So let's let that go. Ask me, where do we want to install? Well, I don't have write permissions. Oh, I do have write permissions there. Well, we're going to do a personal installation anyway. So download it. No key found for key ID. Unless you have a copy of the public key of whoever wrote the software, you're always going to get this error. If you have faith, you shouldn't, but if you do, you can just run the skip gbg check restart, which is what I'm going to do now, 0. And it'll unpack, it'll compile, and it'll load the source. How do I know it's loaded? Well, let's have a look, and let's find, see if the split sequence package exists. It does. Now, I don't really remember much about split sequence. I know it splits sequences, but I don't remember what functions are available. Let's inspect the package. So what I did is, I called up the slime inspector, and I passed it the split sequence package. Well, it's a package, obviously. This is its name. Its name is a string. It has a nickname. It uses the common Lisp package. It is not used by any other packages, I'm sorry. And it has 6 external symbols and 35 internal symbols. I don't know how this looks in the movie, but if you can tell, this text here, here, and here is a slightly blue-gray color. If I hit enter when the cursor is on that text, I inspect recursively whatever the text represents. In this case, I'm going to hit enter on the 6 external symbols, and I get a list of symbols. So what I'm interested in is probably split sequence. I'm going to hit enter again. This is the symbol split sequence. Its name. It's bound to a function. And here's its documentation as a function. I'm going to read this for a second. Okay, this looks like what I want. So let me quit the inspector, jump back to the Lisp file, split sequence, split sequence. The delimiter is space. The sequence is string. Now, this returns a list. So what do I want to do with this? Well, I want to loop over this list. And for each one, I want to write the car. What character? Well, I have the Morse. So I need Morse to character of the Morse car. And again, I need to write this to a stream. We're going to call this character stream. Now we're going to jump out, wrap this with output to string. Call this character stream. Let's jump out, reindent the whole thing. Oops, typo in here. Let's try recompiling the file. No errors, no warnings, no notes. Let's go back here. We said that string to Morse worked, so let's now call Morse to string. I'm going to go, and actually just for fun, I'm going to grab an older output, if I can find one way back here. So I'm going to grab this one, and I'm going to call Morse to string on that. So I get an error. Let's have a look at Morse to string. We see that the Morse car is the empty list. You can see it right here. I'm sorry, not the empty list, it's an empty string. Well, that shouldn't happen. I'm going to use V to jump to the source code of Morse string. If I haven't already talked about V, sorry, I don't remember. Okay, V will jump to the source for a particular frame. So there we go. So this is returning the empty string. Okay, the problem is that this, let's try to remove empty subsuites. So the first thing we do is we're going to test, well, the first thing we're going to do is we're going to close this debugger buffer. We're going to go back to our Lisp code. And I'm going to remove this string, and I'm going to put in, I'm going to perform a quick little test. I'm going to take this, I'm going to paste it here, and I'm going to use Control-X, Control-E, which we said before evaluates the last expression immediately before the cursor. And I noticed that evaluating with this string and passing the new remove empty subsuites parameter returns a list of Morse characters. Just for fun, let's see what it was returning before. Okay, this was the problem. There was a final empty string. So that's good. Let's recompile the file. One style warning. Well, it's redefining a bunch of characters. Let's see. When you're in a buffer which has style warnings or notes, errors, warnings, whatever they may be, you can use Alt-N and Alt-P, slime next note and slime prev note, to jump directly to the note. And when you do jump to the note, you get a variable, you get a string here in the mini buffer telling you what went wrong. The variable string is defined but never used. Well, that makes complete sense. Let's kill that. Let's recompile the file again. Well, Morse to string. Just ignore that thing before. Let's try, let's see. Let's call string to Morse. Let's see what happens. Well, that looks good. Looks very nice. It uppercased it. That makes sense. All of our characters were in uppercase. We lose case information. But maybe this was just a strange coincidence. And maybe string to Morse was actually returning something else that just by chance Morse to string converted back into Marco. Well, I'm going to use Alt Dot again to jump to the source code of string to Morse. Here I am. What I'm going to do here is I'm going to use Control C, Control T to start tracing string to Morse. String to Morse is now traced. Let's jump to the REPL. Just for fun, I'm going to trace Morse to string as well. Control C, Control T, Morse to string, back to the REPL. Now let's call this. And notice that we also got the trace output. So string to Morse returned this, calling Morse to string with this, returned that. So now we can be fairly confident that our functions work as we want them to. Let's jump back to the list file. So let's just re-summarize things briefly. Okay, we've seen the REPL. We've seen most of the major features of the REPL. We've seen the slime debugger. I'm going to pop that up again by passing in a number. Okay, we've seen the slime debugger, all of its different frames. We've seen what you can do with each frame. We've seen the various ways that we can send code from Emacs to Lisp. Okay, we've seen the various ways to inspect the running image to figure out what functions are available, how they're called, what their documentation string is, what they macro expand to, where they're defined. Now, there are just two more ends, bits and pieces that I'm gonna show you. The first is just a very useful feature that's kind of hard to use if you don't know it exists. Let's find one of these that has an interesting object for some value of interesting. Here we go. This stack frame has a value in its local whose printed representation is more or less useless. Doesn't tell us much about what it is. Well, if we go here and we hit enter, we get sent to an inspector which is inspecting the current value of that local, okay, in the call stack. This can be very useful when we have an error and we don't know what went wrong, and we want to see what the values of the data we're working with is and why the error could have been caused. Another thing we can do, if we use I, is we can inspect not only the objects which are already on the call stack, but the value of executing any form within the context of that frame. What does that mean? This means that if there are any special or dynamic variables that are bound, and I hit E here, I can now access those variables with the value they have in that call stack. So for example, trying to think of something that could be different. Let's try package. Actually, let's move sufficiently far out. Let's go all the way out to here. And let's evaluate and inspect package. Well, the package is still Morse. So I can't come up with a good example. Actually, I think I probably can. Now, let's go to the REPL. Well, that's busy. Well, we can go here. Okay. So, suffice to say that if you need to inspect, if you want to calculate something, okay, as if you had a REPL tied to this code, okay, you just hit E. Sorry, not E. Hit I, my mistake. And you can write anything you want in here. Okay. Now, let's abort this. And let's see if our inspector, we closed our inspector. Let's jump a moment back to our Lisp code. Last thing we're going to talk about is the cross-reference facility. This case is so this example is so simple that I can just look at it and I know exactly what's going on. But let's say I had these functions spread over many directories and many files. And I want to add a new required parameter to Morse to string. For example, an encoding parameter. What I need to do now is I need to update everyone who calls Morse to string. How can I find out who calls Morse to string? Slime list callers, Control C less than, which I'm going to do right now. No references found for Morse to string. Oh, well, he's right. There are no references found for Morse to string. Let's try Morse to character, which I know is called someplace. Here we go. Tells me the file name, and it tells me where it's called. The output isn't perfect here, but I don't know why, and we're not going to debug it now. If I hit space, notice that it opens up the file and it sends the buffer. It sends me directly to the form that calls Morse to character. At the same time, I can ask Morse to character, who do you call? Slime list callees. Control C greater than. So these are all the functions that Morse to character calls. They're all unresolved. This means that SBCL doesn't know the file name. You'll notice that they're all internal, so to speak. They're all part of SBCL itself, and so they've been compiled with certain compiler settings. If I, however, go to Morse to string, Control C greater than, notice that it tells me that I call split sequence, and it tells me where I call it. And it tells me that I call Morse to character, and it tells me where I call it. If I hit space here on split sequence, and if I'm patient, take the opportunity to drink some water. It sends me to the place that calls, to the definition, of split sequence. So let's jump back to our list buffer. Don't need this anymore. So that's the useful cross-reference facility. Well, I think this sums up this introduction. I hope you think Slime is cool. In all honesty, Slime kicks ass. If you have any questions, the guys on Slime Devel will be more than happy to help you out. Features are added more or less constantly. There are a couple features that I haven't even begun to mention. Slime has some support for dealing with multiple thread applications, which I haven't talked about. Slime has support for running multiple Lisps simultaneously, very useful when porting code. And I just suggest that you go to the website, have a look, read the mailing lists, and you'll see for yourself. Well, thank you very much. I want to thank the guys from the University of Pavia and Muppets Lab for the machine. I want to remind you again that all the work we did in this video was done on a remote machine. You'll notice, sorry if I add one more thing, I haven't yet told you how to quit. I'm not going to. I'm evil. What you can do is Slime disconnect. What this does is this closes down the connection between Emacs and Swank, but leaves, well, except for the fact that I've Oh, well. Anyway. You know what? There was a good reason why I didn't tell you how to quit Slime and the Lisp. So, thanks. And I hope you enjoyed it.